Hello, this is Mrs. Decker, and in this lesson we'll be learning how to calculate the molarity of a solution. To calculate molarity, you do need to be able to convert between grams and moles, so I want you to pause this video, take a minute, and do these warm-up problems. Okay, so to convert 43 grams of calcium chloride to moles, you start with your 43 grams. You need the molar mass of calcium chloride, which is 110.97 grams over 1 mole. So grams cancels out, and we are left with 0.39 moles of CaCl2. When starting with moles, you start with your 0.45 moles of CuSO4. Put 1 mole on the bottom and your molar mass on the top, which is 159.56 grams. When you multiply that, you should get 71.8 grams of CuSO4. If you're struggling with this, you need to go back and review how to do this before you continue. When we're calculating molarity, what we're really calculating is the concentration of the solution. And molarity is the number of moles of solute dissolved in 1 liter of solution. Molarity is represented with a capital M, and to calculate molarity, you do moles of solute divided by liters of solution, and the units for molarity will be moles over liters. We use this calculation when we're adding a solid to a liquid. So moles is a measure of the amount of a substance. Molarity measures the concentration, how much of the substance is in a specific volume. Our first example problem is, what is the molarity of a solution formed by mixing 10 grams of H2SO4 with enough water to make 100 milliliters of solution? So our given information is 10 grams of H2SO4 and 100 milliliters of solution. And we're looking for the molarity. So remember, our equation for molarity is moles divided by liters. And we're given grams and milliliters, so both of those things need to be converted. So start with the 10 grams of H2SO4 and convert that to moles. So the molar mass is 98.09 grams in 1 mole. So that will give you 0.102 moles. And to convert milliliters to liters, you need to divide by 1,000. There are 1,000 milliliters in 1 liter. So that gives you 0.100 liters. So you do 0.102 divided by 0.1, and that will give you 1.02 moles per liter, or 1.02 molar solution. Example number 2 says how many grams of bromine are needed to prepare 0.5 liters of a 0.01 molar solution of Br2 in water. So we're given our volume and we're given the molarity of the solution. We're asked to find grams. So we have 0.01 molar equals X over 0.5 liters. Solve for X, and you get 0.00500 moles of Br2, and then you need to convert that to grams by multiplying by the molar mass, which is 159.80, and that should give you 0.799 grams of Br2. Example number 3 says calculate the molarity of a solution that contains 268 grams of potassium sulfate in 525 milliliters of solution. So we're given 268 grams of potassium sulfate and 525 milliliters of solution. We're calculating the molarity. So again, we're given grams and milliliters. Both of those need to be converted. So start with 268 grams of potassium sulfate, which is K2SO4, and divide by the molar mass, which is 174, and that will give you 1.54 moles of potassium sulfate. And remember to calculate liters. Take 525 milliliters and divide by 1,000, and that gives you 0.525 liters. So 1.54 divided by 0.525, and that gives you 2.93 molar K2SO4. So now you know how to calculate molarity. There are 8 practice problems for you to work on.